Good morning students, welcome to the next video for the class 10 and the chapter is acid, bases and salt. In the previous class we have talked about the acids and now in this video we are going to talk about the bases. So without wasting our time we have to start the concept of the bases. Dear students, the bases according to the Arrhenius concept, because for the class 10 the Arrhenius concept is most important. So according to the Arrhenius concept, bases are those substances which can furnish OH minus ion in the aqueous solution, So it means that in the presence of the aqueous solution, the bases, the substance which are capable of giving the OH minus ion, they are known as the bases. For example, NaOH, this is the sodium hydroxide. So in the presence of the aqueous solution, it can give or it can furnish Na plus and OH minus ion. Similarly, if I am talking you about the calcium hydroxide, okay, now I am taking the example of the calcium hydroxide. So when the calcium hydroxide is taken, what we can say, the calcium CaOH whole 2, it will give Ca2 plus 2OH minus. In the similar case, if I am talking you about the aluminium hydroxide, it is capable of giving the Al3 plus OH minus 3OH minus. But can you tell that this OH minus can itself release by the dissociation of aluminum hydroxide or calcium hydroxide? No, because it is in the absence of the aqueous solution. The OH minus ion will not release if the aqueous solution is not present. Similarly, in the case of LOH whole 3, you have to write the aqueous solution. So the bases, according to the Arrhenius concept, they have the capability of releasing the OH minus ion. So the substance which are capable to giving the OH minus ion in the aqueous solution, they are termed as in bases. Moving to the next point, we are talking about the classification of acid. So when we are talking about the classifications of acid, we can say classifications of bases, not acid, it is the bases. So bases, it can be classified into two types. The first one is strong bases, and the second one is the weak bases. So how we can distinguish it? So strong bases, they are the substance, they are the substance, or they are the bases, they are the substance which are completely ionized, As I have told you earlier in the previous video that what is the meaning of the completely ionization. Okay, weak base, so they are the substance, they are the substance, or they are the bases, we can say, they are the substances which are partially ionized. Examples of strong bases, examples are NaOH and KOH. These are the strong bases. And when we are talking about the weak bases, it is a CaOH whole 2, NH4OH, okay, and ZnOH whole 2, and so on. So these are the bases by which we can say that these are the ZnOH whole 2. So these are the classifications of the strong bases and weak bases. Whenever I am talking about the completely ionization, it means that in the aqueous solution, the NaOH, 1 mole of NaOH will completely give the 1 mole of OH minus ion. But it is not similar to the weak bases. It means that if the weak basis is getting ionized in the aqueous solution, then it is not necessary that this 1 mole of calcium hydroxide will give the exactly 1 mole of hydroxide ion. It means it will be less than the 1 mole. So it means the ionization of the calcium hydroxide is not completely possible. So that type of bases in which the ionization is not completely possible, they are known as a weak bases. And the bases in which the ionization of the OH minus ion is completely possible, they are known as a strong bases. The examples are here, you have to remember the example. NaOH, KOH are the strong bases, whereas all other bases, they are considered to be as the weak bases. Note it down and we will move to the next topic. Now, before moving to the further topic, we should know about the alkalis. Most of the students, they are not capable of knowing about the alkalis. So, we can say the alkalis are also the bases. Alkalis are also bases that are soluble in water. It means, in other words we can say, or those bases that are soluble in water, that are soluble in water are called alkalis. So I think that you understand this. So you should not even taste the alkalis in the chemistry laboratory. Don't go and taste it, okay? It is always used for the laboratory purpose, or we can say for the testing purpose. They are soapy to touch, bitter and corrosive. So we should never taste them, as they may cause harm to you. In other words, we can also say that all alkalis are bases. All alkalis are bases, but all bases are not alkalis. Bases are not alkalis. Why? Because the alkalis are only the bases which can soluble in water, but not all the bases it can dissolve in water. So the bases which are only soluble in water, they are known as an alkalis, and the bases which are not soluble in water, they are not considered to be as an alkalis. Note it down. Now we will talk about the physical properties of bases. Physical properties of bases. So when we are talking about the physical properties of bases, the first one is the bases have bitter taste. Bases have bitter. It means they taste bitter. For example, like bitter gourd, like neem, and so on. Okay, the next one, they feel soapy to touch. It means that you can even touch the bases, and if it feels like soap, we can say that it contains the bases. Okay, or in all the soaps, in all the detergents, they are soapy to feel and they contains the bases. Moving to the next one, the bases turns red litmus into blue. And the last one, the bases acts as an electrolyte. Electrolytes. So these are the few properties of the bases, few physical properties of the bases. Note it down. Now we will talk about the chemical properties of the bases. So this one is chemical properties, right on the heading, chemical properties of bases. So when I am talking about the chemical properties of bases, we will consider about the reaction with metals. So what will happen? The first one is, if the base, if it will react with the metals, generally some active metals are used for the reaction with the bases. They will produce salt as well as the evolution of the hydrogen gas. For example, you must remember the example, zinc in the solid form, when it reacts with the NaOH, which is in the aqueous form, because then itself it will produce the OH minus ion. So the answer will be Na2ZnO2. Remember this line, the name is sodium zincate, along with the evolution of the hydrogen gas. So zinc, when reacts with the NaOH, it forms the Na2ZnO2 along with the H2 gas. In the similar manner, if I am talking you about the Al plus NaOH in the aqueous solution, so what does it give? It will gives, I am writing here, it will gives NaAlO2 plus H2. The name of this one is sodium, I am writing here, sodium meta-aluminate. Okay, you have to balance it. In the first equation you have to balance, say here Na2, it means you have to put 2 here, and rest of the things this is okay, Zn here. In this cases it is the aluminium NaLO2 and this one, so we can write what we can write, Na2 AlO2, 2Al here, it will becomes 2 and 2H2O here, okay, and it will give 3H2, 2 to the 4 and 2 6. Okay, now this is the balanced chemical equation. So this is a second equation and this one is the first equation, A, and this one is the B number. Note it down so that you can remember it, that how the metals reacts, how the acids or bases it can react with the metals. So zinc, when reacts with the sodium hydroxide, it gives the sodium zincate, and the aluminium, when reacts with the sodium hydroxide, it will give the sodium meta-aluminate. Meta-aluminate, the spelling is META, meta-aluminate. Okay. So moving forward, the second point that we have to study is about the reaction with non-metallic oxide. Non-metallic oxide, and you all know, dear students, that the non-metallic oxides are acidic in nature. They are acidic in nature, and because of this they can react with the bases. So acid plus base, it is a type of a neutralization reaction. So how can we write? Now see, when the carbon dioxide, it reacts with the calcium hydroxide. So see here, the carbon dioxide, it is acidic in nature and it is a non-metal. Carbon is a non-metal and it's oxide. So it will give CaCO3 plus H2O. The name of this one, calcium carbonate. Calcium carbonate. This one is slaked lime. So you can see the non-metallic oxide, it can react with the non-metallic oxide can react with the bases to form the salt and the water. So this much of the reactions you have to learn about the chemical properties of the bases. Now here we have completed about the acids and bases. So when both of them, they react with each other, it means reaction between acids and bases. So what will happen? So dear students, if the acid and base reacts with each other, they forms salts and water. So for example, I can see NaOH plus HCl. This one is the base and this one is the acid. Okay, so we will get NaCl plus H2O. Okay, in the similar manner, CaOH whole 2 plus H2SO4, it will gives CaSO4 plus 2H2O. So it means that at the last time they are always getting the H2O. They are always writing the H2O. Okay. Now, so such type of reactions in which acid and base reacts to form the salt and water, they are known as neutralization reaction. Neutralization reaction. So we all know that. So if anybody asks you about the neutralization reaction, you can say those reactions in which acid and base reacts to form the salt and water, they are known as a neutralization reaction. You have to write down the definition of the neutralization reaction. And what are the products of the neutralization reaction? Of course, it is the salt and the water. What are the reactants of the neutralization reaction? It is the acid and base. We all know about the reactants and products. The substance which undergoes reaction, they are known as the reactant, and the substance which are formed after the reaction, they are known as the product. Now moving to the next topic, that is the effect of dilution on an acid or base. So dear students, what do you mean by the dilution? Any one of you? You can comment over here. So dilution, it simply means the mixing of an acid or base with water is called dilution. Note it down. The mixing of an acid or a base with the water is called dilution, and it decreases. Remember this one. It decreases the concentration of. Concentration means the amount of the solute present in the solution. You already understood about the concentration. It decreases the concentration of H plus ion in acid and OH minus ion in base. Note it down. Now dear students, based on this question, on the basis of this question, one question arises that write down the question, all of you. How is the concentration of, this one is concentration, okay? Concentration of OH minus ion affected when excess base or water. I am asking two questions, okay? This one is A number, this one is B number. Base or water is dissolved in a solution of NaOH. Now see the answer. Now in the first case, the base is added. Now what you have to see that you are giving the answer that how the concentration of OH minus ion is affected. It means that the NaOH itself is a base. So if the base is added to the NaOH, then the concentration of OH minus increases. It means in the base is added. So it will increase the concentration. Now the second one is water. Now see here, you have to add the water in the NaOH, and we all know that the mixing of the water in the NaOH, it causes the dilution. It means the concentration of OH minus, it will decreases. So if the water is added to the NaOH, then the concentration of OH minus decreases. I hope that you understood this. Note it down. This will come in your board examinations. Now one more question comes in the examination, that we all know that the HCl, HNO3, they have the H plus ions in it after the dissociation. So they are showing the acidic behavior. They shows the acidic behavior. Okay. But when we are talking about the alcohol, for example, we are talking about the ethyl alcohol, C2H5OH, or we are talking about the glucose, that is a C6H12O6. Now in both of these cases, the H plus ion are present. In this case is also the H plus ion present. But these two things, alcohols and glucose, does not show acidic behavior. Why? So give your comments over here that why the alcohol and glucose are not acidic, and why the HCl and HNO3, they shows the acidic behavior. So if you can give the answers of this type of questions, it means that your concept is quite clear. So comment over here so that I can understand that you are watching the video very properly and you are understanding this. So guys, this is all about the basis that we are talking about. So keep learning and all the very best. Thank you.